All right. Everybody have a good break? So I'm Adam Culp. This is Clean Application Development. So thank you for coming and listening to me speak. Bear with me. I'm here from America, so I thought, okay, let me go ahead and have a little bit of fun. So I hope I'm not offending anybody. I'm just having a little bit of fun. So just bear with me. Ignore it. It'll go away. But anyway, again, my name's Adam Culp. You can find me on Twitter at Adam Culp. If you have any questions or any comments or anything, please feel free to tweet to me. I do tweet quite a bit, and I do answer questions. A little bit more about me. I'm not going to go into too much depth on it, but I'm an open source contributor. I contribute to a lot of different packages. I'm certified PHP developer. How many certified folks do we have? PHP certified people. Wow, good to see some hands. The rest of you get certified. Again, keep in mind, the certification is not to say we're the best. A certification is so we can go to an employer and say, I know enough to help you on your projects. That's what certifications are for. Doesn't mean you know everything. I'm on the certification advisory board for Zen Framework and also for PHP. So that's one of the reasons why I talk about it a little bit, because I help create the exams. I'm one of the many people on there. I'm also the organizer of SoFlow PHP in South Florida. We have about 950 members in our user group there. I also organize Sunshine PHP Conference, this one. So come out and see us. It's in February. There's a lot worse places you can be in February than Miami. All right, so come see us in Miami in February. I'm also a long-distance ultra runner. So for those of you who don't know what that is, a marathon is 26.2 miles. Ultra means more than. So I run more than 26.2-mile races. So far, I've only gotten up to 76 miles, though. It was 14 hours. I got up to 76 miles. I was trying to get to 100. I didn't quite make it. I was very close, though. I was within 24 miles. I'm also a photography enthusiast and a judo black belt instructor. So whenever you're talking with a potential employer and they put out the ad for the PHP Ninja, that's me. One of the reasons I bring these things up is I love iteration, right? Everything we do as developers, most people in this room are probably developers of PHP, hopefully. But we do a lot of things iterative, right? Whether it's developing, evading project managers is iterative. We get better at that as we practice it. And clean application development, which we're talking about, is also iterative. It is something you get better at over time. It's something that you constantly are cleaning up to the point where you're doing clean application development. Now, this talk is not about clean code. This talk is about clean application development. Clean code is part of that, but clean application development is everything that is encompassed in creating applications. Unfortunately, in 45 minutes, I'm not going to be able to teach you everything that you need to know for clean application development. It's impossible to do that. There's a lot. However, I'm going to cover a lot of key points that will help you on your journey to doing clean application development. I encourage all of you, though, go out and practice the things that I'm going to share. And that's not to say that everything I'm sharing is the only things. It's not to say that what I'm going to share is the best, right? These are just some of the things that I've found that helped me on my journey to perform clean application development. There's no silver bullet. Always be on the lookout for new techniques, new ways to do things. There's constantly people out there sharing their knowledge, much like all the other speakers at this conference and at other conferences. They're sharing techniques. They're sharing their knowledge of what they do to perform clean application development in one fashion or another. One of the resources that I use quite often is Clean Code by Robert C. Martin. Now, on my bookshelf, I have 3 books. This is one of them. I also have another book that is a big favorite of mine, which is Refactoring, and that is from, it's skipping my mind now. Martin Fowler, thank you. And so it's another Martin, right? We got Robert C. Martin, we got Martin Fowler. And then there's a third one, which is the Gang of 4, design patterns. Those are the 3 books I have on my bookshelf. Now, those are not by any means the only books that I read, but they're the 3 most important books that I think that we as developers should at least have read at one time or another. And they're so important to me that I keep them on my bookshelf. Everything else I do digital. But those 3 I want to mark up. My books look really terrible because I mark them up, I write notes, and I do lots of things with them. So anyway, this is one of them, Clean Code. Because initially, although clean application development is not just about the code, initially I'm going to talk a little bit about the code. There's a lot of things when we're coding that can cause and result in bad code and result in bad problems, right? Whether it's short deadlines or whether we take the easy way out and don't take the little bit extra time or perceived a little bit extra time to do these things. Maybe our boss is pushing us, right? Maybe we're just a little bit lazy or we don't know how to do something, so we do the best we can. It's not necessarily the best thing there is to do, but we do the best we can. We try to do it as well as we can. And of course, there's also the time age-old excuse of, I'll come back and clean it up later, right? Do we ever come back and clean it up later? Generally not, because then we have another deadline that we got to meet, so we don't have time to go back and clean up the old ones. So looking at these, though, most of these excuses, because that's all they are is excuses, most of them we are the cause of creating the bad code in the first place. We caused it ourselves. If you go out to my Twitter account, you'll see I have a pinned post there. And my number one thing is stop blaming companies for the bad code, right? Because they didn't write it. You did. So stop blaming them for it. Instead, practice and be a professional and stand up and say no a little bit. It's a pretty neat thread if you're interested. So oddly enough, though, all these things start out innocently. Right? Because, think about it. We're a new developer. How many people have had a chance to work on a brand new project? Brand new code. Okay? We all have, right? A lot of us have. So we were brought into a company and the boss says, hey, can you create this? And we're excited, right? We've got a brand new job. We're really excited about it. Maybe we're very passionate about it because the owner of the company, especially if it's a startup, was very passionate and they get you really excited, right? So what do we do as developers? We go back to our desk and we create it really quick, right? Some little functionality. Do we take the time to unit test? Do we take the time to set up the hosting the way it should be? Do we take time to set up a coding standard and do all these things? No, we don't do any of that. We go and we create it really quick because we want to prove to the boss that he just made a smart investment by hiring us, right? So we go back, we create it really fast, we go back to the boss. Now, the boss doesn't really pay much attention to it at this point. He looks and he says, oh, that's awesome. Imagine if we did this as well. So very excited, we go back to our desk and we do it again, right? We add the new functionality that the boss just said, maybe that would be cool. We go back to him. Again, we didn't go through all the good practices, doing all the things we should have. Now, the boss in the back of his mind is subconsciously starting to think, wait a minute, that was pretty fast. Maybe it's not going to take as long to do this as I thought, right? Because he or she just witnessed you do two things fast, right? Or me, or whoever the case might be. So now they become to expect that, as it becomes iterative, just like all development does. New features, new things, and going back and forth, creating these new things. Well, since we're excited and we didn't follow the best practices, we didn't do the things we should have. Now it starts to steamroll, right? As it gets bigger, our time frames, our time estimates, which most of them are fudged in anyway. But time estimates, we go from being a 1 week thing to a 2 week thing, and pretty soon, all of a sudden, it's a month-long thing. And before you know it, we're up to, well, that'll take 6 months, right? How many people, that's your number one answer? It'll take about 6 months to get that done. You're not being honest. Because that's what happens. Generally, we get to the point where after we've been developing for a while and we haven't been following the best practices, all of a sudden we show our boss, we do the show and tell of some feature that we create and there's bugs, right? So then we go back and we're like, wait a minute, I can't do that again. I don't want to get caught with my pants down. So I got to make sure that I add more time to it. So before you know it, everything is 6 months to get done. But the code is still bad. So that's the thing, is it's a domino effect, and it gets to the point where you've just created a legacy application. It might have been a brand new application, but you created legacy by definition. Another way to look at it is when we're creating code, we are all authors, right? We're creating something. We as developers spend more time reading code than we do writing code. It takes about 70% of our time to read the code. Only 30% of our time is spent writing new code. Now, that's not an exact number. Some of you might be more or less, but for me, I spend about 70% of my time reading code and about 30% writing code. That's me. So essentially, we're authors because somebody's going to be reading it, right? And it's not business. Business people don't look at your code. They have no idea what you wrote. It's developers that look at your code. They know the evil that you created, So keep that in mind. Know that other folks just like yourselves are going to be reading your code in order to write their own code. And by that, through that, they will judge you, right? They will judge you. So just be aware of that, and they talk. Now, that being said, now that we've covered a little bit about the code, what are some of the side effects of this, right? The side effects of creating this bad code is longer time estimates, takes longer to create things. If we're writing bad code, if our code is not optimal, if we aren't following coding standards and some of the other things like performing good object-oriented practices, for instance, then it's harder for somebody to follow behind you and read the code. It takes longer for them to do things because the 70% of time for them to read the code may be longer than that. It may be a slow read, right? Because it's not easy for them. It causes excessive debugging. How many people in here are good at debugging? Be honest, raise your hands. Okay, good. I'm very good at debugging. And now the reason that I'm so good at debugging is because I don't write the best code the first time. And I have to go back and debug it. And practice makes perfect. I've gotten really good at it, right? So debugging is just one of the things that you find when you're doing things like that. Procrastination. How many times do you see a really bad code base and you say, yeah, I want to get on that right now? We don't do that. We avoid it. We procrastinate. I don't want to touch it. It wasn't mine. I didn't create it. And then it creates technical debt. Is everybody aware of technical debt? Yes? Who is not? Who's not aware? Okay. Technical debt, think about it like a credit card, right? So as you're coding, or rather as you're using a credit card, you go out and you buy something, right? And the credit card, the limit gets up to a certain point, whatever point is set by the bank. And when your credit gets all the way up there, then you have to do one of two things with the credit, right? You have to pay it or go bankrupt on it and say, I'm going to forget about that. Code is the same way. Your code can only withstand so much debt, right? Your code, you can only put so much bad code in one place. And eventually you have to somehow pay it off, which is refactor it in little steps, or you just say, I'm going to throw it away and start a whole new application, right? Now, I'm not talking about the times that we say, I'm going to start a whole new application just for the sake of doing it. I'm talking about where the code is really bad enough that you have to start from scratch, right? So anyway, we want to stay away from technical debt. That is technical debt. And technical debt and bad code does translate to financial cost as well, financial losses. There are companies who go broke because of technical debt. It is a very bad thing. If you have developers who are not able to create a new feature in less than 3 months, that company can't sell it, right? So we as developers are not doing our employers any justice at all by creating technical debt in our code because we're basically making them go broke. There are many companies that have just folded their doors. How many people still use MySpace? Okay, prime example of technical debt. It's a nightmare to work in, right? Okay, so how do we typically react with dirty code? I kind of covered this a little bit. So we pad our time estimates, right? As we're coming up with their time estimates, how many people are 100% accurate on their time estimates? Okay, this is a thing that I see quite often. Well, I can tell you, in the last 12 years, I have never missed a time estimate. If you want to know how I did that, catch me outside of this talk. I can tell you how I do it. Because I do. I never miss one. I always hit them right on the head. And it's not by making a number and then doubling it. That is not professional. We don't need to do that, all right? But I know more and more people do that. So anyway, and we typically hide from the code or hide from the application. We become defensive, right? If you're on a team of multiple people, you become defensive. Why did you do that? I didn't do it. I'm not touching it. And then we add developers and we rewrite. I hate the word rewrite. I hate the word rewrite. We should be refactoring applications more and more. This is probably one of the most important parts of clean application development. Stop rewriting applications. If you have a team of, let's say, 4 or 5 developers, right? 4 or 5 developers, and they're making, I'm going to throw a number out there, I'm going to say $100,000 a year per developer, right? I know some make more, some make less, but let's say you have 4 developers or 5 developers, they're making $100,000 a year. Well, if they take a year to create something, That's about $500,000 that the company paid to create an application for 5 developers, maybe more, right? If you're going to rewrite it, what company in their right mind would want to pay another $500,000 for an application? And that's just scratching the surface of the expense that it would take to rewrite an application. That's not to mention customer downtime. It's not to mention all the other things that you need to rewrite an application. Rewriting is just not viable for companies to do. And that's why they're resistant. It's not because you're not properly selling and saying, this application is bad, we need a new one. That's not why they're resistant. They're resistant because money. That's the only reason they resist. They're saying the dollar signs. Oh my God, not only do I have to pay the developers to do it again, but I still have to maintain the old application while they're making the new application. That means I need to hire more developers. And all of a sudden, the cost escalates. So that's why they're resistant to it. So that's why I always say we instead of rewriting, we should be refactoring, because refactoring just doesn't make financial sense. Again, two of the books that another book that I had mentioned earlier was on my bookshelf is Refactoring by Martin Fowler. Now, another book that I haven't finished writing yet is my own Refactoring 101 book. I've been threatening to write it for a long time. I haven't quite finished yet. But if you watch on Twitter, I'm sure I'll announce it when I do. But I'm close. I got quite a few chapters written. And Martin Fowler has actually helped me with part of that. And we were talking about his refactoring book, and we made some changes to the way I'm going to do mine. So that way it's not an exact copy of his, but just PHP specific. Now, if you are interested, I do recommend that you check out Martin Fowler's book. I have a code base out on GitHub at Adam Culp /Refactoring 101. Where I took all the Java code that he used as an example in the book, and I made PHP examples based off of his. So if you're interested in buying his book, that's fine. It's an awesome book. It changed my life in development. It's a great book. But I wrote PHP code to go along with it if you're interested there. So that being said, I mean, we covered some things here in relation to code, and again, these are the major things, but there's a lot more behind clean application development. But just on what we've covered so far, with the shortened development time of having better code, better applications, easier to onboard new developers, because if your code's cleaner, it's easier to get a developer up and running, right? If you hire somebody new and they're faced with bad code, it takes a lot longer for them to become productive. So with all these things and less bugs and all that, it just makes sense to try to follow these good practices from the beginning. One of those is, of course, a coding standard. How many people at work have a standard coding standard? Just one standard. Everybody on your team uses it 100%. The hands went down. There was a bunch there. I was so excited, and all of a sudden they went down. So a coding standard is really important. And if you're working in a team, everybody should use the same one. Now, there's a few different ways to do that. I always recommend, let your team vote on it. Now, don't even mention tabs versus spaces. Stay away from that. But, the other important things, you want to make sure you cover those, right? And you want to make sure that everybody votes on them. Now, what I'm about to say now is a little bit controversial sometimes, but they're not always going to agree, right? So at that point, the architect makes the final decision. The application architect who's the lead, there might be multiples of them, depending on the size of your project, but the application architect is the one who makes the final choice based on how everybody voted, right? It's not the individual developers. But yet the individual developers have to follow it, and you should follow it. If somebody does not follow it, they can go find another job. And I'm very brutal on that. If you can't follow the coding standard that the team has decided to do, sometimes the architect might have had to decide it. It's the architect's application, right? What that person says goes, and everybody else should do it as well. Coding standard is that important because if they're not following the coding standard, that means onboarding new developers takes longer. It means the code is not good enough. Chances are it's going to introduce bugs. There's a lot more code smells because of this. It is vital that everybody's following the same coding standard. Now, there's a lot of coding standards out there. There is no one-size-fits-all. Most frameworks that we use nowadays, whether it's Symfony or Zend or whatever, they have a coding standard for their project. I'd recommend to use that as a starting point if you've decided to follow a framework. If you're not following a certain framework, there's always the PHP Framework Interoperability Group, or the FIG. There's a lot of PSRs out there to kind of start with. Now, I'm not saying to take those and run with them, right? But if you don't have a starting point, they are a great starting point, right? Most frameworks in PHP these days are using the FIG as a starting point in one fashion or another, right? I don't care how controversial it is, depending on the framework that you're using, it might be more or less controversial. But when it comes right down to it, they all started there, right? So I would say use that as a starting point and kind of go from there. But the most important thing is that everybody's using it. Whatever the coding standard you use is not important, but it's important that everybody on the team is using the same one. That is vital. So just as a starting point of some things that I like to make sure that we broach about coding standards is, names should be clear. We should have clear-cut names, right? So if we have a name like elapsed, what does that mean? What does elapsed mean? You see a variable with the name elapsed. Something a little bit more clear than that might be elapsed time in days. It tells me exactly what that is, right? The same thing with created days. What is created days? Maybe something clearer like days since creation might be a little bit easier to understand, and so on. I mean, there's others, but just make sure that your names are clear. Make sure that they're defined, so that way they know, everybody knows. Stay away from variables of the same name, right? So if you have a product, and do we need a product info or do we need product data? What's the difference between all those, right? In your project, you should come up with a name and say, well, product is always this, right? We don't need one to say product info, another one to say product data. What's the difference between those, right? So you want to make sure it's clear, make sure you define it. These are the sorts of things that you want to make sure your coding standards cover, so that way we're not wondering, what should I do? As developers, it makes our job a lot easier if some of these things are predefined. And it makes it easier on new people coming in. Stay away from bad characters. What I mean by that is a lowercase l. What's the difference between a lowercase l and a capital I? Can you read that? Do you know which one it is? Chances are not. So it's better just to stay away from the lowercase l if you can help it. So also, like an uppercase O is a little bit difficult. Uppercase I, again, another difficult one. So you're not always going to stay away from them, but just as a general rule, try to shy away from them in some way. Also, maybe predefine some grammar, right? If you're using class names, if you're defining classes, try to make them descriptive. Something like customer or account or product, company, maybe cart, something like that. Make them descriptive. Now, when you're naming your classes solve a problem. That is the purpose of a class. It solves a problem. So your class, that name of that class should give an idea of what problem it's solving. And that's what these do, right? So the customer class solves the problem of customer. All the methods within that class are going to be one step closer to solving the problem. And that's the way classes should be done. And then you have verbs for your different actions. Like, for instance, in your customer class where you're trying to solve the customer problem, you might have a get customer, or it might be something along those lines, or maybe close account for the account class. And then also make sure that you're clearly defining different keywords that you use. So don't use fetch in one place and get in another place. What's the difference between those? Define one within your coding standard and say, okay, we're always going to use fetch, or we're always going to use get. Something along that line makes it easier. Also, in terms of code, we want to make sure that we're keeping things like our function names. Keep them as short as you can, or the functions as short as you can. The names as short as you can. You want them descriptive, but the function itself should be short. A function, so a class solves a problem. A function does one thing towards solving that problem. So you might need a lot of functions in order to solve the problem, what you're trying to solve with the class. But if you're writing a function or a method to do one thing, how big does it need to be? It doesn't take a lot of lines of code to do something, right? It doesn't take a lot of lines of code to accomplish something. So functions should be nice and short. There's a lot of places out there tell you how long it should be. Some places say a screen, right? One screen should be a function. So if your function is exceeding the real estate you have on your screen, maybe it's a little bit too long. But then again, I know some of you are using these fonts that are only this big, so a screen could be deceptive, right? You might be able to fit 100 lines on your screen. That doesn't make it right. I use Code Sniffer on all my code, so that way I know if something has exceeded a certain threshold. In my functions, I always put a threshold of 20. I don't want a function to be longer than 20 lines. Now, occasionally it happens. Yes, it does, but it's rare. Because again, a function does one thing, doesn't take a lot of code to do one thing. And a function should be single purpose. If you find that you're getting a little bit confused with your function, it's not doing one thing. It's not single purpose. Kind of break something out. You pull some of that code out into another function that does one thing. And then make sure you name it all appropriately. Now, along that line, though, as we're working inside of our code and we're working with our functions and things like that, I always tell people it's not necessarily always easy to find bad code, right? I mean, we can, like if we're listening to the radio and we hear a song, we can tell if the song's bad. You know, it's like your fingernails on a chalkboard, right? You can, ooh, that's bad. I don't like it. But we might not necessarily be able to do that with code. Oftentimes, I can, just at a glance, look at code and say, oh man, that's bad. I don't know why. I just glanced at it. But it takes a little bit more time to dig into it, right? And much like the people who wrote songs, you might listen to a song and say, that song's not really that great. It doesn't appeal to me. I don't listen to it anymore. But does that mean you can write a song? You know, so just because we know something's bad doesn't mean we can fix it. Another thing about code is that code shouldn't really require a lot of comments. You shouldn't need to really put a lot of comments in your code. Now, please don't tweet, Adam said not to code, or not to comment code. I didn't say that, right? I'm not saying don't comment code. I'm saying that you should be able to write your comments more meaningful in some sort of way so there's not a lot of them. A lot of comments in a code base is actually a sign. It's a code smell. I generally aim for about 25% of my lines of code is comments. That's my personal goal. So if I'm using Code Sniffer and it tells me that my code has about 20% comments compared to lines of code, I know maybe I didn't comment it as well as I should for the next person following behind me. How can we do that? You may be asking, how do I do that? How do I let less comments, or how do I write more comments? So as an example, let's take this. So here we have an if statement, and we're putting a comment here that says, check to see if an employee is eligible for full benefits, right? And in this if statement, we're checking some flag. We're checking to see if it's an hourly flag or if there's an hourly flag set. And we're checking to see if the age is greater than 65, right? So with that, because we're doing multiple conditions there, we had to pretty much put a comment. Otherwise, who would know what it is, right? But imagine if we broke that out into a method, and that method was called is eligible for full benefits. Do we now have to write a comment there? Probably not, because the comment is telling you what it's going to do, right? Now, so then we pull that if statement out, we put it as an if statement within the function that we just created. We might not need a comment there. Now again, I'm not saying don't comment your code. When I comment a code, usually what I'll do is I don't comment to explain the code. Because if you're explaining the code, you didn't code well, right? Now again, business doesn't read your code, developers read your code. So you don't need to be too over descriptive. They're developers, they should know what you're doing, right? But if you're explaining bad code because it's not clear enough, that is not the proper way to do a comment, right? Don't explain bad code. Instead, what I do is I write a comment telling the intent of the code. So I don't have to tell exactly what the code's doing. I just say, here's what I'm planning to do over the next 2, 3, 10 lines, and kind of leave it at that. Now, I also find that as the code gets refactored over time, because it does get refactored over time, as people read your code and they fix things, they're going to change it. So you want to make your comments so they don't become deprecated too quickly, right? You don't want to get to the point where you have comments in your code that don't mean anything anymore. So if you write something that explains the intent of the code, chances are that comment is going to be valuable for a lot longer time period, right? Because the intent of the code generally is not going to change. How the end result might happen, that will change, but the comment won't change because the intent is going to remain. It's going to remain solid. So that's why I explained the intent of the code. Now, there's a lot of things to go along with this. We call them code smells. Code smells is where certain patterns within the code kind of highlight there may be an issue there. Doesn't mean the code is bad. Okay, none of the code smells mean the code is bad. It just means that there's a likelihood that there might be bad code there. Like incomplete error handling. How many people handle errors throughout their code? All the time. We should handle it all the time. We should handle all those errors. We want it to be graceful, right? Especially if it's user-facing. The users should always be, get some good error handling there. And we've made it a lot easier in PHP 7, so it should be a lot better now. Memory leaks. If you have memory leaks in your code, it used to be a bad thing. It's not quite as prominent anymore in PHP applications. We've cleaned up some of the common things that people do to hurt themselves. Maybe race conditions, where you have a variable that might be getting set, but it's out of sequence or something like that. Got to watch for race conditions. These are code smells. Inconsistent coding standards. Again, that one I can't hit enough. Coding standards are important. Uninitialized variables. So where you're calling a variable, and if you turn error reporting on 100%, which you should, in your development environments, you should report all the errors. I want to know everything, right? And if you have some, then you need to refactor. You need to fix it so that you don't have those. Initializing variables is one of the common ones. People turn off error reporting because they don't want PHP to tell them you didn't initialize this variable, so we turn it off. Instead, initialize the variable. Make your code clean. Code lacks a clear purpose. Maybe your functions are longer than 20 lines, and it's a lot harder to find the clear purpose of it. Functions may be doing too many things. Globals are being used. Don't use globals. Too many comments are in the code. And if you do turn on error reporting 100% in your development environments, if you're seeing notices, warnings, and of course fatal errors, fix those. Get those out of the way. I oftentimes, so I work for RogueWave. I used to work for Zen, but we got acquired by RogueWave a few years ago. And so that's what I do. My day job is helping people refactor code. That's my superpower. I do it all the time. I'm going out to talk with companies, and they're showing me their code. They're showing me their terrible code, right? There's a lot of it out there. And one of the first things I'll notice is I'll be in a development environment, because I always say, set up a development environment for me so I can do some static analysis, take a look at the code, see what's going on. And I don't see any errors. And I'm like, and I expect errors, right? Especially if the code's legacy. There's always errors. There's always warnings. There's always notices. And it's turned off. I say, why is that turned off? And they say, well, because if we turn it on, we get so many warning notices, we can't find what we're actually looking for. We can't find the error we actually want. And that's the purpose. That's why we want to always have it on. We always want to see all those warnings, all those notices. Because after you clean those up, everything else that's left is legitimate, right? If you have an error in your code, but you have 200 notices telling you that you didn't initialize variables, it makes it a lot harder to find the error. Something that makes it easier to find all these code smells is Code Sniffer. I like Code Sniffer. I use it every day, every hour. I'm constantly using Code Sniffer to go through the code, and using set sniffs, I tell it what to look for in my code. Anybody use Code Sniffer? Anybody not heard of it? Okay, a couple people. Yeah, check it out. It's really awesome. It's a PHP library, so you're using PHP to analyze PHP. All right, so it's good stuff. And in most modern IDEs, whether you're using Zen Studio or PHP Storm, most of them you can build this in, right? You can just download the library and tell your IDE where to find the library and tell it to run it against your project, right? So it does it in real time, and you can get all these results. I also use Code Sniffer in my source control. Whether I'm using Subversion or whether I'm using Git, I run it into source control. I create hooks in the source control, so that way whenever anybody does a commit, it runs Code Sniffer. If Code Sniffer finds something they can't commit, it makes them fix it before they can commit. I don't want your nasty code. I want good code. So we put Code Sniffer out there in front to kind of weed that stuff out. And that's a great way to use it. There's other static analysis tools that work really well also. I would encourage you to just use something, but Code Sniffer is free, it's out there, and it's created by the Germans. Got any Germans in the room? The Germans? Not many. Wow, okay. Another really helpful thing with clean application development is peer review, code reviews. Always do this. Anybody actually implement this at work or even on your personal projects? I could say over the last 4 or 5 years, I have never released a line of code that somebody hasn't reviewed. And that's even my open source projects. I find somebody that will review it for me, whether it's a coworker, whether it's somebody else. Matthew Ware of Finney gets tired of hearing from me. He's an excellent code reviewer. There's many other good people at doing code reviews as well, but I don't put any code out there unless somebody else has reviewed it, because I am not the most perfect programmer. None of us are. There's no such thing. So it's always good to have a second set of eyes on there. Sometimes they might find bad things. Sometimes they might find things and say, well, wait a minute, maybe if you did it a little bit different, sure, your code works, but maybe if you did it a little bit different, it would be faster or better. So it's always good to do. Another part of clean application development is, of course, patterns, using patterns. And this is one of the books that I mentioned before, the blue one, which is the Gang of Four's design pattern book. Now, there's also a PHP one that needs recreated. It's a little bit outdated. It is actually on PHP 4 and 5 mixed. So it's a little bit outdated, but it's still good. It's still valid. The examples in there are mostly PHP 4, though. I think PHP Architect is in the middle of having somebody redo that. We'll see if it comes out soon. But anyway, now, as you're reading these, make sure you set aside a decent enough time, because you will take naps. They are not exciting reads, right? They're very boring. And so we want to make sure that you set aside extra time, but they are great books. I read both of these at the same time. So I read one till I'm ready to fall asleep, then I pick up the other one, and then I'm really asleep. But anyway, it's just good. They're really good books. Something else that can really help us with that, though, because they've already implemented some patterns, is using a framework. Now, there are lots of frameworks out there. How many Symfony framework people do we have? How many Zen framework? How many Laravel? How many are using Laravel at your companies? What are they going to do in 5 years? Anyway. It's just a side dig, not a big deal. But frameworks are awesome, and we should use frameworks, right? Because it makes it easier for our companies to hire people. You can say, do you know Laravel? Do you know Zen? Do you know Symfony? It makes it easier to bring developers up to standard on your code and get things done quickly. There's a lot of things. I mean, frameworks have kind of gone through a recent renovation. We're going to talk a little bit about that, but we want to make sure that we're using frameworks, because they really help us with our code. I don't care which one you use, but use one, and don't use your own. Don't use your own for your company. Let me rephrase that. Please write a framework. Everybody should write your own framework, but then never use it at your company. Use a mainstream framework at your company, right? So one that more people will know, one that has more eyeballs on it, finding security fixes and things like that. I would never put my framework in a company and then expect them to be able to hire people, say, do you know Adam's framework? Because nobody does, right? It's my framework. It's something that I created. And by the same token, we should also strive on a constant basis to create better frameworks. So maybe you will create the next Laravel, or the next CodeIgniter, or the next Zend or Symfony. There's always room for improvement. If I were to look at something like this, an architectural diagram, looking at this, I can probably pretty much tell what this is, right? There's long rows here. I can see that there's categories like fiction and bios and things. I can probably pretty much tell this is a library. Right? The architecture is kind of clear in it. Or if I look at something like these, the architecture is very clear, right? However, in our applications today, The architecture is maybe not so clear. How much do you have to dig into a current Symfony application to tell what it's doing? From a top level of a Laravel application, can you tell what it's going to do? The same thing for Zend. Can you really tell from the top level of your applications what it's going to do? Generally not. We are not there yet, folks. There's a lot of room for improvement. Now we're getting closer because throughout the framework's lifetime, right, we started out with component libraries. We had a bunch of different component libraries back in the early 2000s. And that's kind of gotten a little bit better because then we made full stack frameworks instead of components. So that way everything kind of worked together. But we discovered very quickly that maybe that wasn't the best way to go. We started using MVC. Then we started going to micro frameworks, right? I don't need it so heavy, only give me micro frameworks. Then we started using action and response frameworks that did things a little bit faster, more precise. Then we started coming around to components, right? Now Symfony and Zend are componentized. You can use bits and pieces and not have to use the whole thing, right? Again, we're becoming more modern. Maybe we're using middlewares. Maybe we're using SlimPHP. Maybe we're using Zend Expressive. So that way we can be micro and be componentized all at the same time, right? So again, the progression of frameworks is starting to come back around. Now CakePHP even, and CodeIgniter, some of these other ones, they're becoming more componentized. So now you can use them as middleware. The PHP Fig came out with PSR 7 and the new PSR 15, which is about to ready to go into vote. So that way we can say, I use the middleware interfaces. I use the interfaces, so now all of our applications can understand each other, right? So if you want to use some Symfony components, you want to use some Zend components, you want to use something from Slim, you can use those because they understand how each other talk. You know, now, not all frameworks are created that way today, but for the most part, a lot of them are using some of these things so that way they can communicate with each other. So now you can go back to your companies and say, okay, we're not going to use a set framework. Instead, I'm going to use components from all of them because they all talk to each other. Now it becomes a lot easier to hire because I don't have to hire a Zend framework developer. I don't have to hire a Symfony developer. I hire a PHP developer because now we all know how to work together, right? So anyway, that being said, Composer, of course, is an important thing for all this, right? Because with Composer, it allows us to bring all these pieces together, get our autoloaders created. Now, how many people are using Packagist in Composer? Good. How many people are using private Packagist? For those of you how many people have your own frameworks or your own libraries at work, but you're not using Composer? How many? I don't see any. I see a couple. Okay. But you can use private packages now and host it yourself, so now you don't have to worry about putting something on Packagist and being public, right? You can use your own libraries internally that you might not want public. So it makes it really easy to do that. You can even use Composer and normal Composer to do that, but private Packagist works out well like that. We should also be using unit testing. Unit tests allow us to test our code in small little bits and pieces to ensure that things are functional. We should all be doing multiple levels of testing. Unit testing, of course, is one of them, where we can go in and we can test it, see if something is owned by, in this example, and test it to see if that's done. And if it is, return true. The next level of this, though, is after we get done testing, of course, if testing is very important, we should do it for all of our applications. And if it's so important, shouldn't we do it first? Testing should be done first. Most of the teams that I work with, it takes a little bit of time to teach them and teach their QA engineers, but testing should be done first. We should be getting enough requirements from business so then our QA engineers can write the tests. Why are developers writing tests? Developers shouldn't be writing tests. QA engineers should be writing tests. Developers should be writing code to make the test pass. Right? And if we get requirements early enough and full enough, that's not as much of an issue. So we can go through and write our unit tests and then write the code to make the test pass. How long does your code need to be to make a test pass? It's a lot less than what most people are writing these days. Well, then what we end up with is a much better thing where you don't have your QA engineer catching stuff at the back, right? They're able to catch things early on, so now it's not so much of a major thing. a lot of us are probably using Agile or some flavor of Agile to do our development. How many of you leave ample time at the end for quality testing? Generally, we develop up until the last day, and then we throw everything over at the wall at the QA folks and say, okay, now test it, it's got to go live tomorrow, right? And so they end up looking like this. They're catching everything at the end. And of course, that's coming into Agile. Agile is important. Please follow some method or some way of doing things more iteratively. That is what Agile is about. Well, actually, there's two things Agile is about. One is making sure the business is engaged, so that way you get those requirements the right way. And the second thing is making sure things are done more timely in smaller increments so that the business can recover if it fails, right? Because development does fail. I usually say that Agile was not created for developers. Agile was created for business. It makes developers able to do their job better through the process if you're following some way of doing it. But it was actually created for business because business wasn't involved, and they were starting to complain and say, I don't know what's going on. I don't know what you're creating. I told you I wanted this, right? And so Agile kind of came about, and we said, okay, well, let's change that then. Let's get you more involved. It's hard to do. It's not easy to do, but you should be trying to get them involved. And put out the charts. There are burn-down charts and things that are part of Agile. If you're posting those, then the business knows ahead of time if you're falling short, right? If you don't let them know, of course they're going to be angry. They just sold the feature you've been working on for the last 2 weeks, or maybe longer. If you don't tell them ahead of time that it's failing, they have customers waiting on it, right? So we have to tell them ahead of time. That's what those charts are for, is to let them know. Be professional. Always strive to do things in a repetitive way. Make sure you're documenting. Make sure you're doing things that work yourself out of a job, essentially. My job is to work myself out of a job. I don't want to have a job tomorrow. That makes me able to take vacations without having to be on call. It also means that I'm promotable, because now the company doesn't rely on me to do something. If you do things in such a way that you're not replaceable because you have information that nobody else can use, you just made it so you can never be promoted. Congratulations. You want a raise? I can't give you a raise. I can't promote you, right? So then you end up quitting and going to another job and do the same thing there. That's why developers hop from one job to the next is because they can't get properly compensated in their previous one. Not always. I mean, I realize there's bad employers out there. Okay, I'm not trying to make it sound like it's all our fault. It's not. But often it is. So clean application development, as we've seen, it's about being iterative. It's about learning, constantly seeing new things. Make sure we have clear architecture. Create clean architecture if we don't have it. Follow a coding standard. Make sure you're doing testing. Use frameworks. Use some form of Agile development to make your development cycles easier for companies to work with you. Learn to say no. If you tell your employer that you need to do something in a certain way, make sure that you can substantiate that. And if you can substantiate it, there's a point where you say no. I can't do what you're asking me to do, right? I can't build that bad code. I can't build that application the way that you're saying to do it. I can't use MD5 to hash my passwords, right? Say no. They hired you to be a professional. Live up to that. They're paying you a professional salary. If they're not paying you a professional salary, go find somebody who will. But they are out there, right? Be a professional because they hired you to do that. Learn how to say no. It's really important. And live up to the term of being professional. I put some resources here. Again, I have a blog at geekyboy.com, aptly named. And I also have a podcast, but I don't podcast quite as regularly as I should at Run Geek Radio. Again, some other things here that might be helpful to you. I don't know that I have time for questions, but that's the end of my talk. Feel free to see me after if you have any questions or comments. If I offended you, tell me how I did, so that way I can help you understand that I really didn't. But please, thank you for everybody for coming and listening. I hope you enjoyed it.